Hey, boo! Did I scare you? You ready to learn about the greatest common factor and the least common multiple? Because it's about to happen live. And you're going to also learn a shortcut to finding the greatest common factor. So, sit back and relax. No, don't relax. Sit back and lock in and focus and get ready for these awesome videos. I'll see you soon.
Have you ever wondered what's so great about the greatest common factor? Or maybe you're even wondering what that even means. Well, first let's review what a factor is. Then we'll discuss what it means to have common factors. And finally, we'll get into that whole thing about being the greatest. A factor is a whole number that's part of a multiplication problem. So if you ask, what factors does a number have? You're asking, what numbers could you multiply together to get that number? For example, if you multiply 3 and 4 together, you get 12. That means that both 3 and 4 are factors of 12. Or if you multiply 6 and 7 together, you get 42. So 6 and 7 are factors of 42.
Seriously, he couldn't think of no other numbers in this whole entire universe to use? Okay.
But it's important to realize that numbers can have more than two factors. Take 12, for example. We multiplied 3 times 4 together to get 12. But we could also have gotten 12 by multiplying 2 times 6. That means 2, 3, 4, and 6 are all factors of 12. Can you think of any other whole numbers you can multiply together to get 12? Well, there's 1 times 12, of course, but that's kind of obvious because you can multiply any number by 1 and get back that number itself. That means that 1 is always a factor of any number, and the number itself is always one of its own factors. Those factors, 1 and the number itself, might seem just a little too easy to find, which is why they're called trivial factors. So now we have a list of all the possible factors of 12. 1, 2, 3, 4, 6, and 12. Those are the only whole numbers that can be multiplied together to get 12. But what does it mean for factors to be common factors? Well, if two friends like playing the same sport, you'd say they have a common interest, right? Similarly, if two numbers have the same factor, they have a common factor. To actually see what a common factor is, let's get another number and figure out what its factors are. Let's do that with 42 since we already know that 6 and 7 are factors. What other whole numbers can we multiply to get 42? Well, there's 2 times 21, and 3 times 14 also gives you 42. Besides that, the only factors of 42 are its trivial factors of 1 and 42. So let's put all of those factors into another factor list. Now, when we put these two factor lists next to each other, do you notice anything? Yep, there are several numbers that are common to both lists. Of course, 12 and 42 both share the factor 1, since all numbers have a factor of 1. But they also share the factors 2, 3, and 6. That's a lot of common factors. I'll bet these numbers would be good friends, even though there are some factors that they don't have in common. But now we can ask, what's their greatest common factor? Yep, that would be the number 6 because it's the common factor that has the largest value. Greatest basically just means the largest. So you can think of it as the largest common factor if that helps you remember better. So to find the greatest common factor of any two numbers, all you have to do is list all of their factors and pick the one that has the largest value that's in both lists. It's as simple as that. But why would you ever want to do that anyway? Well, one very common use for the greatest common factor is for simplifying a fraction. A fraction is inherently made up of two numbers. If the numerator and denominator have a common factor, that means that the fraction is not as simple as it could be because it contains factors that could have been canceled. For example, if you have the fraction 12 over 42, you know it can be simplified because 12 and 42 have common factors. The way most people would probably try to simplify 12 over 42 is by noticing that they are both even numbers, which means that they have a common factor of 2. So you could divide both the top and the bottom by 2 to get the...
Think divisibility rules. This is when you can think of your divisibility rules to find out what you can divide each of those numbers by. So anytime you want to pull out your resource in your math binder and use your divisibility rules, it can really help you with this. Just saying.
over 21. That is simpler than 12 over 42, but it's not as simple as the fraction could be, because 6 and 21 still share a common factor of 3 that can be canceled. But what if right at the beginning of the problem, you knew that the greatest common factor that these numbers shared was 6? Then, if you simplified it by dividing both the top and the bottom of the fraction by 6, you'd get the result 2 over 7. And 2 over 7 is the simplest form this fraction can take. So knowing the greatest common factor can help you simplify a fraction in basically just one step. Of course, if it takes a lot more steps to figure out what the greatest common factor is, it might not save you as much time as you'd like. Okay, I hope that helps you understand what the greatest common factor is. Keep practicing and be sure to check out mathantics.com for help with other math topics.
Okay, now you're going to find the shortcut on how to find the GCF. Love this strategy. I only learned about it about 2 years ago, maybe 3 years ago, and it's the only way I will try to find the GCF now. I think it's so awesome. What this person is doing, this example they're doing, I want you to write it down in your binder, in your notes, as they're doing it, so you have a model of it. Okay, enjoy.
Very short video on how to use the ladder method to find the greatest common factor. You already learned what the greatest common factor is. This is just a quick sort of shortcut method. So we have this question: what is the GCF of 36 and 126? First thing we're going to do is just write 36 and 126. And we're going to draw ourselves a little L for the ladder method. And now we're just going to find a number that we know we can divide both of these by. So I know I can divide both of those by 2. So now I'm going to divide. How many times does 2 go into 36? Maybe you'd have to do some math over on the side to figure that out, but just to give a shortcut, I'm going to tell us that it goes in 18 times. And how many times does 2 go into 126? If we divide 126 by 2, we will get 63. Make the next rung of our ladder. And we're going to find out what's a number that I know that can go into 18 and 63. Well, I might know that 3 will go into both of those.
I just can't help myself. Okay, I get so excited about this kind of stuff. Look, it's our divisibility rule. Remember, to be divisible by 3, the sum of the digits in the number, so if you add them together, have to equal a number that is divisible by 3. So 1 plus 8 is 9, and you can do 9 divided by 3 is 3, nice and evenly. 6 plus 3 is 9, so you can do 9 divided by 3, nice and evenly. So both 18 and 63, we know that this 3 can go into both of them evenly because of our divisibility rules. So feel free to get out your divisibility rules resource anytime you want when you're doing these kind of problems. And also, you are welcome to use a multiplication chart because they can really help you with factors and things that can go into numbers. Okay, I'm leaving. I'm going to try not to come back. Okay, goodbye.
So we'll divide them both by 3. 18 divided by 3 gives us 6. 63 divided by 3 gives us 21. Make another rung of my ladder. See if there's a number that goes into both of these. Well, again, I might know that 3 will go into both because 3 goes into 6 2 times. And of course, 21 divided by 3 equals 7. Now, when I look here, is there any number that can be divided that goes into 2 and 7? The answer is no. So, I am done. So what I want to do now is just look right here. Multiply all these numbers that go down this side of my ladder. So multiply 2 times 3 times 3. And of course, 2 times 3 is 6. Times 3 is 18. And that is my GCF. That's how you use the ladder method. Unlocked.
Okay, my loves. Last short video on least common multiple. And again, it means exactly what it says. The common multiple that is the smallest one between two numbers. Okay. See you soon. I'll try not to bust in. I'll try not to. I can't help it.
Now that you've watched our video about the GCF, let's learn another TLA that mathematicians call the LCM. Sounds like FUN to me. LCM stands for least common multiple. Notice the word common is common to both the greatest common factor and the least common multiple. To get the greatest common factor, or GCF, you take two or more numbers, find the factors that they have in common, and pick the greatest one. To get the least common multiple, or LCM, You take two or more numbers, find the multiples that they have in common, and pick the smallest or least one. Sounds pretty simple, right? Let's try finding the least common multiple of these two numbers, 3 and 4. We'll start by making multiples of each number, which just means multiplying them by the sequence of whole numbers, like 1, 2, 3, 4, 5, and so on. Or, if you remember how to do skip counting, that's the same as making multiples of a number. Counting by twos is just making multiples of 2. 2, 4, 6, 8, 10, 12, and so on. So to find multiples of 3, you can skip count by threes. 3, 6, 9, 12, 15, 18, 21, and so on. And to find multiples of 4, you can skip count by fours. 4, 8, 12, 16, 20, 24, 28, and so on. Did you notice any multiples that 3 and 4 have in common? Yep, 12 is a multiple of both 3 and 4. But is it their least common multiple? Also yes, because it's the first one that we encountered and we listed the multiples in order from smallest to largest. If we had kept making larger and larger multiples, we'd see that 3 and 4 do have other common multiples, like 24, 36, 48, 60. But they're all bigger than 12. So 12 is the LCM of 3 and 4. This method of finding the least common multiple by making lists of multiples and then choosing the smallest one common to both lists is easy to understand, but it has a few drawbacks. The first drawback is that you don't know up front how many multiples you'll need to list in order to find the least common multiple. In this example, we could have stopped as soon as we got to the multiple 12 in each list, but we didn't know that when we started. What if you had started by listing the first 20 multiples of 3 and then moved on to listing multiples of 4? That would result in a lot of unnecessary work, since in hindsight, you only needed to list the first 4 multiples of 3. So, if you're going to use this basic method, I'd recommend that you start by just calculating a few multiples of each number to see if you find a common multiple. Then if you don't, keep on calculating a few more each time until you do. The second drawback is that if the numbers are bigger and harder to find multiples, either by skip counting or just by using multiplication, then this method can be a lot of work. It's not hard at all to find the LCM of 2 and 5 by listing their multiples, because those are so easy to skip count or calculate. Skip counting by 2 gives you 2, 4, 6, 8, 10, and skip counting by 5 gives you 5, 10. Well, see, we already found the least common multiple is 10. But what if you want to find the least common multiple for slightly bigger numbers like these, 12 and 14? Let's start by making 5 multiples of each and see what happens. 1 12 is 12, 2 12s is 24. Well, we made 5 multiples of each number, and we haven't found a multiple that they have in common yet. Let's try 5 more of each. 6 12s is 72. Ah, there we go. The number 84 is in both lists, and since it's the first common multiple we encountered, it's got to be the least common multiple of 12 and 14. But that was quite a bit of work, wasn't it? Fortunately, there's another method that you can use to find the LCM that sometimes makes the job a little easier. It's called the prime factorization method, and I'll show you how to do it in the next video.
Actually, he's not going to show you how to do that in the next video because I'm going to stop it right there. Okay? I'll show you a shortcut using that ladder method. So, we're done with GCF and LCM. Thank you for being patient and watching a longer video with the 2 skills combined. They're not bad, and now you can go practice them on your learning path. Love you.